Hello friends, in continuation with the last lecture, now we'll talk about the remaining static characteristic of measuring instruments or the measuring devices in the instrumentation. Okay, the next property is the repeatability. Repeatability, just trying to measure the uh, output or the any value number of times, right? So it is actually defined as the ability uh, of an instrument to produce a group of the measurements of the same measured quantity. Means the same measured quantity will be just trying to measure the number of times, provided that the it's or else the keeping the its physical parameters or the experimental conditions same, then we can have the repeatability of the measurement. It is also related to, or it is related to the performance of the system when all the determinations are carried out by operator in the same conditions. This is what I said it earlier. So the operating conditions has to be remain same, then we can have the repeatability of that instruments and we can define its performance. Now the next property is the reproducibility. Okay, repeatability and the next property is the reproducibility. It is actually the probability that the instrument will perform its assigned function for a specified period of the time, and when the hysteresis is also included. So hysteresis, we'll see in the moment later that what is meant by the hysteresis, but let's talk about the reproducibility. This is the probability that the instrument will perform its assigned function for the specified period of time. So will give us the some certain time and ask the instrument to do its functioning or try to measure the certain values in a particular direction. The reproducibility of the system depends on the individual parts, manufacturing methods, and the users or the operators, those who are just trying to operate the instruments. So individual parts of the which of what kind of the parts we have used, then the in which method it is manufactured, and the who is operating that instruments will give us the reproducibility in the instrument. Now the next property is the drift. Drift is coming generally due to the temperature, right? Is the nothing but the vibrations of the instrument opposes the functioning of certain conditions of the or certain measurements. Okay, so that is the drift actually. So the variation of the output of the instrument from the desired value for a certain or given input due to the change in its sensitivity inputs like temperature, component instabilities. Means over the period of the time, what happens that the due to the aging effect, and that the when the system when we turn on, then obviously the some part, because of the aging effect, some parts gets heated up, so the temperature actually reduces the sensitivity of the instrument. Even the components becomes unstable, so that the output will not get the what we expect to have, and this will give us the drift in the measurement. For example, strain gauge in a balanced condition without a compensating strain gauge. Okay, if we don't have the compensating strain gauge, then we can have the strain gauge is in the it will not be in the balance condition. Okay, the obviously this will give us the some drift. Okay, and now the graph shows the input output characteristic of the instrument when the ambient temperature changes after a calibration. So what happens that if suppose if we just try to measure the graph initially like this, we expect like this, but happens that when we turn on the instrument, so sometimes that what happens that we get the result like this. Okay, so in the it just gets shifted, though the behavior of the or the nature of the curve remains the same, but they are actually giving the something different values. Okay, this is something like a negative zero drift or the positive zero drift. This is coming because of the temperature. after the calibration. So the ambient temperature change causes the change in the resistance of the strain gauge. So this results in the bridge becoming unbalanced, and as a consequences there is an output at a zero strain which corresponds to the zero drift of an instrument. So means if there is no input applied, still at the output we will get the some strain. So this is nothing but that comes under the zero drifts of an instruments. Now further, this resistance change also affects the sensitivity of the instrument, which results in the change of slope of the input output curve. So this changes the slope of the input output curve, and we can say that there is a error in the measurement. So the total error involved due to the drift is combined effect of the zero drift and the sensitivity drift. So it is actually the combination of the both the drifts coming, that is zero drift as well as the sensitivity drift. To minimize such a kind of the errors or the drifts in the measurement, it is always advisable to switch on the instrument at least half an hour. Means we should turn on the instrument and keep it for the some time before the commencement of the instrument, so which ensures the electronic components reach a steady state temperature. Generally this happens when we are trying to turn on our motorbike during the winter season, because of the temperature outside is quite cold one, and we are not able to ignite the engine by using our battery. So that sometimes we need to kick off the motorcycle or motorbike and keep it for the some time, and then we can start driving the motor, so that we can have the smooth driving of that motorcycle. This is one of the example can have the drift. Now, the another characteristic is nothing but the hysteresis. Hysteresis is nothing but we are just trying to measure the output value by just changing the input in the one direction and again reverting back, or else increasing the value of the input and again try to follow the same path but in the opposite direction, so decrease the value, and you can get the hysteresis curve. So now during the measurement of this any physical quantity, there is a small change in the measured value. What is that small change in the measured value when the input is varied in increasing manner and in the decreasing manner? This is termed as the hysteresis. You might be quite familiar with the another kind of the hysteresis in the magnetic hysteresis loop. This is something like a BH curve or the MH curve. We can have something like for the ferromagnetic material. We can have the such a type of the behavior, something like we just go over this, increasing the field, then again decrease the field in the same direction, but the it follows like this curve, and again go on the negative maxima, and then again increase the field in the positive direction, and we can get such a kind of. So this is something like a hysteresis behavior of the material, we can call it as, okay, or the hysteresis property. Now it is also defined as the magnitude of the error caused in the output for a given input when this value is approached from the ascending and then the descending order. Just ascend the input and then descend it, so that we can get the some error or the difference in the both the curves. We expect to have the similar kind of the curve, but no, we'll get the deviate from its original path, so or the earlier path, so that this will give us the hysteresis. This error is reduced by selecting the proper gears, lubricants, providing the suitable heat treatment to the material. A hysteresis is usually expressed as a percentage change of the full-scale output measured at the 50% of the full-scale input level. Okay, so this is something like the hysteresis. Percentage change of the full-scale output measured at the 50% of the full-scale input level. Okay, so this is 50% of the full scale, and this is how we can now the another property is the dead zone. Okay, dead zone is something like it doesn't exist over there. Okay, dead. it is dead, not able to measure or give its output value for the certain regions. It is a maximum value of the input parameter for which the instrument does not respond. So this is maximum value. Even if we are just trying to change the input parameter, output will not going to get changed, or so not able to get the output. So this gives us the dead zone. So for example, hysteresis caused by the mechanical instrument due to the Coulomb friction. So this is something we can consider over here. Hysteresis loop due to the Coulomb's friction. This is idealized straight line, okay, straight line behavior, but because of the hysteresis error, we can have the suppose increasing manner. If we go over there, and this is the behavior we are getting it, and if we just try to decrease the value input for this region, if we go over maxima and try to decrease the input, the output remains the same, and then it takes some input to change, and then it starts giving its response, and it goes over there. If in the even input becomes a 0, still it, showing the reading in the opposite direction, and this is what the we can get. So region between these two is nothing but the dead zone. Okay, this is nothing but the dead zone, and this is threshold. Threshold is nothing but the below which the instrument is not at all responding. It is showing the 0 output. It is for the even the positive input is applied to the that instrument. Okay, this is what the we can call it as a dead zone. So this region is called of the input, and for the output as well we can call it as a dead zone. And the last property of the last characteristic is nothing but the resolution. When the input of the instrument is increased slowly from the some arbitrary value, the output does not change until the certain definite increment is exceeded. This is known as the resolution. What is resolution here? When the input of an instrument is increased slowly from the some arbitrary value, the output does not change until the certain definite increment is exceeded, is known as the resolution. It uh, also be defined as the input change which produces the measurable change in the output. So input has to change so that the it gives us the some output value or changes in the output one. Thus the it is the ability of a measuring instrument measuring system including observer to discriminate between the nearly equal values. So we should able to discriminate the changes happening or the nearly to equal values. Thank you.